Hello, in this video, I will do an integration by parts with definite integral. So um, you're usually you're used to seeing unbounded, but this time we'll have bounded. So the rule for definite integral is integration from a to b. So what you do is you do the by you do the u to v from a to b minus the integral of v du. So there's like two parts you have to do. So let me do an example. So let's say we got to integrate from 0 to 1 of tan inverse of x dx. So we're definitely going to do integration by parts, but we have boundaries. So I mean, I tried doing this problem by first taking the integration by parts, get the answer, and then apply the boundaries, but that won't work. You have to do the rule first. You have to do exactly this rule. So let's take the integration by parts. So first we got to figure out what's our u and what's our dv. First off, could you do tabular method? I don't think so. Because it would be really confusing. Tabular method won't work for this one. So we're just gonna figure out our u. So our u, I believe our u will be tan inverse of x. And my dv is my leftover, so my dv is 1 dx. Okay, so then you would do is take the du dx. And then what's the derivative of tan inverse of x? That's a special one. That is 1 over 1 plus x squared. And then we got to get du by itself, so I have to get rid of this dx. So I'm going to multiply both sides by dx. Okay, so on this, it's just du. And then on the right, it's 1 over 1 plus x squared dx. Okay, so that is my du. Now let's find our v. So how do you find v? You just basically take the integration of dv. So what's the integration of 1 dx? That is just x. Okay, then you apply the rule. uv minus integration of v du. So our u is tan inverse of x. And then our v is x. So it's going to be x. And then our u is tan inverse x. So it's tan inverse x minus the integration from a to b. So our lower boundary is 0 and our upper boundary is 1. And then our v is x. And then our du is 1 over 1 plus x squared dx. So you can clean this up a bit. So this, if you apply the rule, this would be from 0 to 1. Okay, and so let's clean this up a bit. So x times 1 over 1 plus x squared, you can rewrite that as x over 1 plus x squared dx. Uh, let's just do this first before we do this part. So how do we take the integration of x over 1 plus x squared? You're going to most likely do u substitution, right? So my u would be 1 plus x squared. And then my du would be, the derivative of 1 is 0. The derivative of x squared is 2x, and then dx, right? Is there anything we need to get rid of or something we don't need? We have this x and we have this dx, but we don't have this 2. So to get rid of this 2, I'm going to multiply both sides by the reciprocal of 2, which is 1/2. So on the left, 1/2 times du is 1/2 du. And then on the right, 2 times 1/2, that cancels, so you're just left with x dx. Okay. So this would be 1 plus x squared is u. And then you can replace x dx with 1/2 du. So 1/2 is a constant, so take it out if you like. And then you have 0 to 1, and then you have 1 over u du. Then what you're going to do is, what is the integration of 1 over u? That's a special one. It's ln of u. Then you still have this 1/2. So that would be 1/2 ln of u. We said u was 1 plus x squared. And yeah, and then let's take the boundary. So okay, so on the left side, we're going to apply the rule x tan inverse of x from 0 to 1 minus, and then we already took the integral of this, so then we have to apply the binomial, the boundaries. Okay, which part would you like to do? Let's do the left part first. So do the upper minus the lower boundary. So let's do 1 first. So it would be 1 tan inverse, and then our upper boundary is 1 minus, and then you do the lower boundary. So it's 0 times tan inverse of 0. So I don't have to really worry about this because 0 times anything is 0. And then this is 1 times tan inverse of 1, so that's tan inverse of 1. So what is tan inverse of 1? So what they're saying is, what degree in radians is going to give you a tangent of positive 1? And that would be pi over 4, because here's pi over 4. Remember, tangent is y over x, so coordinates of pi over 4 is radical 2 over 2, radical 2 over 2, so that would be pi over 4 minus 0. And then let's do this part. So keep in mind there is a minus right in the middle. So I'm going to put like brackets. Now we're going to do the upper minus the lower. So let's do the upper first. So it's 1/2 ln of 1 plus x is 1. 1 square is 1, so you could just say 1 minus the lower boundary. So it's 1/2 ln of 1 plus 0. So this is going to be 1/2 ln, and then 1 plus 1 is 2, minus 1/2 ln of 1 plus 0 is 1. Okay, so this one right here, ln of 1, that's 0, and 0 times 1/2, so this just becomes 0. So you're just left with 1/2 ln of 2, and then keep in mind there is a minus right in the middle, so you could put a minus, and then on this side, pi over 4 minus 0 is just pi over 4. So your final answer, you can express it as pi over 4 minus ln of 2 over 2. And that will be your final answer. Okay, so you can't just take the integration and then you can't just take the integration by parts and then do the upper minus the lower boundary. You have to use this rule exactly. So it's uv and then the upper minus the lower minus the integration of this. So write this somewhere in your notes. And we are done for this example.